Hello everyone, in this video I will explain about the Night Rider light circuit. So the equipment we use is our own laptop and Proteus software, which is ICs and arrays. The components we use is 6V DC power, 55 timer IC, 4017 IC, 33 kilo ohm resistor, 220 ohm resistor, 100 ohm resistor, 2.2 microfarad electrolytic capacitor, and red LED. So this is the procedure from construct the schematic diagram until the PCB layout. This procedure will be explained on the next video. So the evaluation of results in the Night Rider circuit, the 555 IC is wired as an oscillator stable mode. The output of the 555 is directly connected to the input of a 4017 decade counter. The input of the 4017 counter is called the clock line. The 10 outputs Q0 to Q9 become active one at a time. On the rising edge of the waveform from the 555 IC, each output can deliver about 20 mA, but a LED should not be connected to the output without a current limiting resistor. So in this circuit, we're using 100 and 220 ohm resistor. Using 63mm LEDs, the display can be placed in the front of a model car to give a very realistic effect. The same outputs can be taken to driver transistors to produce a large version of the display. So the suggestion for improvement of future work. Our suggestion is we can try to create the Night Rider blind cane tip. This is project innovation from Wintershim's students. So I will put the link for reference on the description.
Warmest welcome to lecturer Dr. Mohamed bin Misman. My name is Nivekha Ramadas from Group 7 and my partner name is Mohamed Hakim bin Mohamed Hassan al Tohamy. Now I am going to explain the circuit that we did. The title was given for us is Night Rider circuit. First we save our project as Group 7 Project BEEC1333. Now let me explain the components that we used. Find for an E555 and place aside. Then find for NC4017 which has 14 pins. Now all the components are connected as well and all the LEDs are lighted up as well. Now let we see the missing parts in the circuit, and almost all the LEDs and battery are missing in the simulation. Next step is have to edit the LED components. Find for LED under miscellaneous category and repeat this to all the LEDs. Now delete the battery and replace with T block. Follow the same wire to connect the T block that we did for battery. This is the complete circuit after we replace all the missing components. Now recheck again, got components missing or not, and all the components are connected as well. Now look over for the electrical rules and check the netlist. This is netlist and almost all is connected. At last, save again the circuit. That's all for the circuit, and let's see for PCB layout.
Okay, now we already transferred the schematic circuit into PCB layout using LS Professional. So this is the editing windows, and this is the list of components. So we just right click and choose component. So we can adjust them, and then we continue to place other component. We can notice that each time we place our components on the editing window, balance number of components will be decreased. So we continue to place other components. So after we finish place all the components, we can see the list component is empty, and we can see many greens and yellow lines. So the yellow lines refer to proper location of our component, and green line is the electrical connection of our circuit. Okay, now we will set the board edge. We choose 2D graphic box mode, and we change to board edge, and we click the board edge. So this will be the border of our PCB layout. Next, we will set the thread width and for our connections. we go to this symbol, which is design rule manager, and we set the net class to signal, and we set the trace style to T50, and we choose pair 1 horizontal and vertical. We set both to the bottom couple. Okay, next we can place physical electrical connection to the electric circuit. Here we use auto rotor to automatically route electrical parts for the circuit. So this is the auto rotor. We set wire grid to 70 and via grid to 50, and we can begin the routing. So the routing is finished. So this is the complete PCB layout. So the blue lines is the bottom copper, which is bottom connection. So lastly, we will print out the layout. So we go to output and choose print. And then we set to this. And then we click OK. So this is the PCB layout. So that's all.